Imagine your most critical AI system. It ingests data, reasons, and then acts on your behalf. Now imagine that this stream of data is full of noise, missing values, or even malicious signals. Without the presence of constraints, your AI will absorb these toxins and amplify them. Those concepts that we term as data guardrails or the vaccination. They are the controls that we embed at the earliest stage to validate inputs, monitor signals, and trace every decision. Welcome to this special technical episode of the Aether Vector. I am Lewis Maverick Adams, a recovering quant who spends his days at our think tank labs in fun. We identify global shifts at the think tank, prototype solutions in our labs, and then deploy capital through our fund. Today, I want to speak with you, not lecture, to paint a vivid picture of data guardrails. Imagine we're sitting across from each other, coffee in hand, exploring how data fuels the systems that run your bank account and monitor your health. We'll explore how leading banks, regulators, and biotech firms implement data guardrails in the real world. We'll dive deep into case studies, tooling, architectures, and regulatory frameworks to understand not just why guardrails matter, but how to build them. This isn't a theoretical talk. We're going into the trenches with machine learning engineers, risk officers, regulators, and clinicians. While my background is banking, we will extend beyond finance into life sciences, diagnostics, and even lab automation. Each domain shares the same challenge, ensuring that AI and machine learning systems only ingest trusted, timely, and traceable data. Over the course of our conversation, we will learn from those who have done it at scale, their successes, pitfalls, and everything in between. I promise to keep the slides at a minimum. We'll use the visuals only to punctuate certain points, such as the end of each segment. Each visual will display for only about 10 seconds to reinforce what you just heard. Ready? Let's dive in. So, what are data guardrails and why should you care? Think of data guardrails as seatbelts and airbags for your artificial intelligence pipelines. You may never notice them until something goes wrong. When an AI system ingests raw data, the slightest corruption, such as an extra zero in a transaction or a mislabeled clinical sample, can cascade into catastrophic decisions. Guardrails are the technical and procedural controls that validate inputs, monitor signals, and preserve traceability, or otherwise that we have complete understanding of the data journey when it becomes necessary. In the Ether Vector framework, we talk about the triple guardrail, the data, the model, and market guardrails, but today we're focusing on the first line of defense. At ingest, we check schemas, data types, and ranges. As data flows, we detect anomalies and drift. Downstream, we log lineage so that any prediction can be traced back to its origin. This isn't theoretical. In the area of generative and agentic AI, our systems fetch information autonomously, making observability and traceability mission critical. Before modern platforms, data quality checks were sporadic and manual. Engineers would run a few SQL queries and hope for the best. Now, continuous observability is embedded into code. We've moved from test at deployment to real time monitoring and audit ready pipelines. Once the data is in motion, we run real time anomaly detectors on operational metrics and external signals such as market feeds, social media, genomic sequencing instruments to catch drift, fraud, or system failures. We also capture lineage, metadata that traces every transformation or change in the data, from raw ingestion through each model, calculation, and aggregation. This allows auditors and engineers at point in time to answer where and how did this number originate. That shift underpins everything we'll discuss. So why does all this matter now? Why now? The triple guardrail framework, data, model, and market guardrails was introduced as part of our research apparatus at Aether Vector to address the inherent risk that AI can malfunction at machine speed. Data guardrails are the first line of defense. If we ingest corrupted information, No amount of model tuning will save us. Generative and agentic AI is and has been exponentially adopted across industry, sometimes with incomplete governance. This exponential adoption of generative and agentic AI has heightened this risk as systems autonomously fetch data, call APIs, and act on unvetted signals. The safest, logical, and probabilistic roadmap to concurrently achieve speed and safety is to codify these constraints into our pipelines. Data guardrails can span multiple layers in order to execute the necessary steps of data safety. Below is a summary of categories and representative tools. I'm going to bring the table up on the screen. So as you can see in this table, we have 4 categories, and each category has a purpose. In addition, each category has a number of options or tools or applications. Some are open source and others are commercial. Let's quickly walk through them. For data observability, the purpose is to verify the schema or the composite data structure and provide assurance of the completeness and freshness of the data. For lineage and metadata, the purpose is to provide ability to track data flows and their related dependencies and also build audit trails. For anomaly and drift detection, the purpose is to detect unexpected patterns and distribution shifts in real time. This is based on a baseline plus real time data exchange. And finally, we have streaming and signal integration. The purpose is to ingest and process high velocity signals from internal and external sources and leveraging these signals into the overall data safety and data guardrail construct. To build a robust data guardrail, organizations often combine these capabilities. As a practical example, a fraud prevention pipeline may use Kafka for ingestion, Great Expectations for schema validation, Monte Carlo for observability, Aries for drift detection, and Secoda for lineage. Let's talk about the ecosystem you can tap into. In the open source world, projects like Great Expectations and SodaSeek will help you verify schema conformance and data freshness. Platforms like OpenLineage and Apache Atlas track upstream and downstream dependencies so you can answer, where did this number come from in seconds? Libraries such as Evidently AI and Y Labs provide real time drift detection, and streaming engines like Kafka, Flink, and Bing funnel high level velocity data from sensors, markets, and lab equipment. Commercial vendors take these concepts further. Monte Carlo and Databand wrap observability into managed services. Secoda and Calibra build enterprise-grade lineage maps. Aries and Databricks deliver production drift detection. Confluent and Palantir Foundry integrate streaming and analytics. These aren't just logos on a slide, they are building blocks you'll experiment with in the labs after the show. To illustrate the landscape, I'll flash a bar chart at the end of this segment showing the number of open source versus commercial tools across observability, lineage, anomaly detection, and streaming categories. Abstract frameworks become real when people use them. In the world of payment, one standout example that we can talk about is checkout.com. Checkout.com processes thousands of payment pipelines and must guarantee data reliability across Snowflake, Airflow, and dbt. Checkout.com needed to monitor thousands of pipelines feeding Snowflake and Airflow. Early on, engineers wrote manual monitors for each pipeline, but manual checks couldn't scale, so the team adopted monitors as code from Monte Carlo. Data quality checks live alongside their data models, their dbt models, and each deployment triggers machine learning based anomaly detection. The result? A self-service observability platform where incidents are triggered quickly and engineers no longer fly blind. So what does this look like? Monitors as code. Engineers configure monitors directly in the repository. harmonizing testing and deployment, central UI and incident management. Monte Carlo's dashboard presents all monitors and incidents in one place, which expedites resolution. And last, machine learning monitors. Machine learning based detectors adapt to changing load patterns and reduce false positives compared with static thresholds. Another example that we can talk about is retail brokerage Robinhood. Over at Robinhood, the problem was speed. Trading platforms process thousands of metrics per second, and static thresholds produce noise. In other words, threshold based alerts are insufficient for complex patterns. Their architecture, Kafka to ingest metrics, FOSS to produce streams, InfluxDB to store time series, implements adaptive statistical anomaly detection. Instead of staring at dashboards, risk teams now receive targeted alerts and respond before users feel the pain. So, what does this look like? Kafka ingests metrics, FOSS processes streams, InfluxDB stores and analyzes time series data. In terms of reasoning, standard deviation based thresholds adapt to non stationary time series, reducing alert fatigue. Another example we can discuss, it's Paystack, part of Stripe's global network, which automated data lineage and unified governance. At Paystack, a fintech acquired by Stripe, the firm struggled with documentation sprawled across Google Sheets and Notion. The firm adopted Secoda, which allowed for unified documentation and automated lineage. Every data source and transformation is mapped, giving engineers and business users a unified governance layer. This democratization of lineage reduces manual effort and speeds decision making. Paystack highlights that data guardrails are as much about democratizing access as about governance. When everyone can trace data, decision making and confidence in the data improves. As we conducted the market research and analysis for this podcast, we located other examples, even outside the world of so called high finance. Freedom Pay, a payment technology provider, implemented a unified observability platform and slashed mean time to resolution from weeks to hours. FreedomPay accomplished this by centralizing telemetry and adopting a unified set of tools. When they did this, engineers stopped arguing about metrics and started resolving issues. Another example, SailPoint, an identity security company, reduced its metrics volume by 33%, 33%, using Grafana's adaptive metrics, cutting data costs and simplifying dashboards in terms of structure, content, and count. MediaKind, a video streaming firm, pre-processed logs before ingestion and reduced log ingestion by up to 80%, reducing cost and improving time to insight. Across the industry, these approaches reduce mean time to resolution, cut costs, and improve trust in data. Observability isn't an academic exercise, it frees talent to focus on product innovation rather than firefighting. Further, these examples demonstrate that investment in continuous observability yields tangible results across industries, truly making a business case for data guardrails. Now let's step into the lab. A global biopharma company consolidated its phase 2 and 3 trials across North America and Europe into a single Azure and Databricks dashboard. The dashboard integrates electronic data capture, finance, and monitoring systems, consolidating them into a single source of truth. This single source of truth had the effect of reducing manual reconciliation and ensuring traceability. Operational reporting became 60% faster, and management gained 120% real time visibility across more than 120 sites. With unified data governance, underperforming sites were flagged quickly and resources reallocated, ensuring compliance and improving patient outcomes. In genomics, pipelines often lack metadata. Intermediate files vanish into obscure folders, making reproducibility impossible. The Musk on-ramp platform captures metadata for every results, records tool versions, and stores intermediate data in structured repositories. Researchers can now reproduce analyses and audit decisions. This level of traceability transforms messy bioinformatics into a reproducible science. Diagnostics labs benefit from similar guardrails. Real time access to test results and automatic logging of transformations ensure AI models only use fresh, validated data. Patient safety and regulatory compliance depend on these unseen but vital processes. Regulation often feels like a burden, but it can be a map showing where the industry is headed. The EU AI Act entered into force on the 1st of August 2024 and will be fully in enforcement on the 2nd of August in 2026. Ban practices and AI literacy obligations took effect on the 2nd of February 2025, and general purpose AI obligations began on the 2nd of August 2025, and high risk AI systems and regulated projects enjoy an extended transition period until the 2nd of August in 27. The Act classifies systems by risk and mandates transparency, human oversight, and post market monitoring. We'll show a timeline at the end of this segment to place these things next to other frameworks. In the United States, the NIST AI Risk Management Framework structures AI governance into four functions: govern, map, measure, and manage. Govern establishes roles and policies. Map defines the system's purpose and users. Measure develops metrics for accuracy, fairness, and security. And manage turns insight into action with continuous monitoring and retraining. These functions reinforce the need for input validation and auditability. Other regulators echo these themes. Singapore's Monetary Authority urges board oversight, AI inventories, risk assessments, and lifecycle controls covering data management, fairness, and transparency. The Bank for International Settlements warns central banks about data security, confidentiality, and hallucination risk, and proposes an adaptive governance framework. Finally, the European Medicines Agency and the FDA guiding principles emphasize human centric design, data provenance, interpretability, risk based performance assessment, and plain language communication. Governance, it's no longer optional, it is woven into the fabric of AI innovation. Let me sketch a blueprint. At the ingestion layer, secure APIs or message queues like Kafka and Kinesis enforce schema checks, value ranges, and digital signatures. Stream processors such as Flink or Kafka streams fuse internal data with external signals like market prices, sentiment, and biosignals and run real-time drift detectors. Continuous monitors like Aries and evidently compare input distributions against baselines and log transformations for audit. Finally, lineage stores such as OpenLineage or Cicada maintain a graph of transformations. This layered design enables oversight at computational speed. But technology needs humans. We talk about the quant human, a hybrid role at Aether Vector combining mathematics, machine intelligence, economics, and risk governance. Similar to a data steward, this person designs schemas, defines quality thresholds, tunes anomaly detectors, and communicates findings to executives. Without such roles, guardrails become an unloved tool. At the board level, leaders must ask, do we have an inventory of all data sources feeding our models? Are external signals monitored for emerging risks? Can we trace any decision back to its source? Are responsibilities defined when anomalies occur? Do we have the talent to bridge technical, business, and regulatory domains? These questions turn guardrails and two, strategic infrastructure. We've traveled from the conceptual to the concrete, from seatbelts for data streams to case studies spanning payments and genomics, regulatory timelines, and layered architectures. What emerges is a clear message. Data guardrails are not a compliance checkbox, but an enabler of trust and innovation. By embedding validation, monitoring, and lineage into your pipelines, you free your teams to focus on discovery and growth. At Aether Vector, we identify global shifts at the think tank, test prototypes in our labs, and deploy capital through our fund. I invite you to experiment and install great expectations, map your lineage with open lineage, explore anomaly detection. Thank you for joining me on this journey. Thank you for joining us here at Aether Vector. Until next time, this is Louis Maverick Adams signing off.